So hello again, the recording has now started. Welcome to Cloud Robotics Working Group meeting. Today we have a somewhat of a short notice talk, so I appreciate you coming in quite last minute, but it should be about more AI talking to ROSBags. But instead of me trying to sum up what your research and paper is about, I'll hand over to Leifu and Sahar Salimpour. Sorry if that pronunciation is terrible. I'll let you introduce yourselves and take over.
Yeah, hi everybody. Today I would like to introduce the work between me from Zurich University of Applied Science and the University of Turku, which Sahar is from. And we are working on the ROSBag MCP servers. And if I could share my screen. Yeah. Yeah. Yeah, so what we are working on is another ROSBag MCP server, which I actually checked the previous work group meeting that Bago is actually one of kind of our similar repo. But actually we started our work before them, so we released a bit late and we have a little different approach. So I would like to introduce what we are working on. So our MCP server is to analyze robot data with large language model and enabling new applications in agentic embodied AI. So our key objective is to bridge the gap between the natural language and the robotic data analysis. And by leveraging MCP protocols, we provide a standardized way for language models to work directly with complex robot data. And the vision is agentic embodied AI, which is a trend for now. And we want to develop a kind of robot brain that interacts with humans through natural language. And this includes giving commands, interpreting sensor data, and making robotics accessible to people actually without technical expertise. And about the current research, actually has explored quite a lot about the ROS and the LM integrations, including the single agent system ROSA, the multi-agent framework like RAI, and also ROS LM that exposes ROS actions and services as the tools. And for the ROSBag analysis, there's the traditional ways like Foxglove Studio, Plotjagler, these to visualize the ROSBag data, and also with the new technology like Higgs technology and Bago, which has already been presented here in our work group. They have a different approach. Higgs is a kind of event-driven analysis with the AI-generated triggers, but if it's not predefined event, maybe it will miss some data in the ROSBag. And Bago is a database-centric approach, but it has some limitation on the complex queries, which maybe the large language model cannot handle. So our work builds on all these efforts and try to solve the limitations. And actually, robotic data is quite hard to analyze. So because ROSBags contains a multimodal binary formatted data that LLM cannot directly read, and data sets are large and often exceed context limits. And current solutions are fragmented and lack a standardized interface. So we need a way for the LLMs to interact, to make the robotic data truly conversational. Our solution is using the MCP protocol. It uses a JSON RPC client server design and is platform independent, and exposes 16 specialized robotics tools with specialized robotics tools. Most importantly, it allows natural language interaction with the robot data. And we also benchmarked it across 8 different language models. This is the main overview of the agentic chain of the ROSBag MCP servers. The diagram illustrates the different components, and what we are working on is mainly the MCP server. And here is the 16 tools available in our server. The capability is to read various ROSBag formats from the file systems and overview data flow between the MCP server and the client, which is linked to the LM providers in the MCP host. And we support OpenAI, Claude, and we also developed our own MCP Lab for the test. Here is the tool category and the capabilities. We organized into core data access, message retrieval, filtering, domain-specific analysis like trajectory analysis and LiDAR data analysis, and several different robot data-specific tools. And also we developed some visualization tools such as the time series plots. Together, they cover the essential workflows for the robotic data analysis. And here is some example of our tool schema, and also the example of our MCP tool request, which you could get from our site. It ensures that LM can call the tools reliably. For example, the retrieving messages within a time range requires a topic name, timestamp, and the backpath is optional. And this is the MCP Lab, which we developed to evaluate what we have developed for the ROSBag server. It is a testing and benchmarking platform with a remote connection support, which we can run on our laptop instead of in the robot. It connects to multiple LM providers and generates metrics for systematic comparisons of model performance. Yeah. And I don't know if you can see clearly, this is an example with our MCP server with the Claude desktop and also our customized MCP Lab web interface. They give a different overview, but the answer is similar. And this workflow demonstrate how natural language translates into structured analysis. And here is a table of our test. We used 10 queries to ask in 8 with 8 models. And here we tested both proprietary and open source models, and the tasks range from retrieving sensor data to generating trajectory plots. The required tools indicates the baseline tools that should be invoked for each query. And among the tested models, Claude Sonnet 4 and Kimi K2 demonstrate the most consistent performance. They both completed all the tasks all the queries, and followed closely by ChatGPT, GPT-5 Mini. And some of the models are small. That's why they have they frequently failed to complete multi-step analytic tasks, and sometimes they just produce incomplete result and or required some kind of human correction. This is the distribution of the response time of the models and also the number of tools used in our tests. But this is only consider the successful response across the models. And also because Llama 4 can only answer 2 out of 10, so we just remove it from the result. From the first image figure, it demonstrates that Kimi K2 and Claude 4 has the most stable and predictable response time, and they have tight distributions around and indicates reliable and efficient tool calling behaviors, while Q1 and other smaller models exhibit higher response time variabilities. It could, because of the wrong decision-making process, that these models may take unnecessary computation approaches rather than efficient using the actual necessary tools. And the second is the number of tools used in the query, in the answers. Results that Kimi K2, Claude 4, and Claude 3.7 has better performance with the most efficient tool usage patterns. And they could require fewer tools to complete the same tasks, while other smaller models or other open source models has less efficiency behavior in our test. But maybe we need more tests to see actual behavior, like more consistent. And with all our tests, we identified some key success factors. A clear schema would improve the accuracy, and simpler arguments works better because argument complexity could be challenged for the smaller models because they could frequently fail to construct valid parameter sets, and models sometimes struggle to preserve context across sequential cores, as models often forget previously established parameters like the folder path of this ROSBag or something like that. Also, too many tools could result the reduce of success rate, particularly when tools share similar functionalities or overlapping parameter spaces. So these observations suggest that optimal MCP server design requires the balance between functionality and the interface simplicity. Sahar is going to show some live demo of our MCP server, so I will give the screen for her.
Hello, everyone. I'm Sahar. I'm doing my research in Finland, University of Turku. And as Lei mentioned, I'm going to do some live demo for our MCP ROSBag server. So let me share the screen. Okay. Okay. As Lei mentioned, can you hear me?
Yeah.
Maybe I can just, okay. As Lei mentioned, we tested our MCP ROSBag in the MCP Lab that we released it together with this MCP ROSBag. the key features of this MCP kind of focused interface is that it has more computational metrics, like the latency, number of tools, number of tokens, and it's kind of similar to the cloudy desktop, but actually here you can choose different providers from, let's say, like Anthropic. We could choose like different, we can set different models, and then it has the debug mode. It can show different servers and the number of tools. So I think for the people who work with the MCP servers, this interface is quite kind of user-friendly and also easy to use different models. So we tested our ROSBag mainly in this MCP Lab and cloudy desktop. So here I can actually test a few tasks. Or to save time, I actually just wrote the task before, so
Sahar disconnected.
It looks like. I think we can wait for a minute. I guess maybe this is a good opportunity for questions that Lei can answer if we're waiting for Sahar. So does anyone have any questions? Throw them out if you do.
I guess the usual question comes to mind, which is completeness, right? Like in the problem with LLMs and all of these ML tools is that they, unlike model-based techniques where you can prove correctness and soundness and all of these things, you cannot prove that about LLM-based techniques. So I'm actually not necessarily interested in hearing what you think the completeness is, but how do you think these things should be measured, right? So I guess maybe a starting point could be the list that you have in the terms of the questions that you asked. But I guess my question is, how can you be sure that you will always get the right answer? Obviously, you've already found cases where you don't get the right answer, and that's fine. Those models are sort of sorted out already. But the ones where you did get a check mark, how can we be sure that if the data changes, you get the right response, right? And the next question would be, how do you know that small variances of asking the question do not derail the model, right? Instead of saying this, you say that, or you phrase the question slightly differently. Do you have any thoughts on that? I know this is an open-ended question. I'm just trying to hear your thoughts.
Actually, for that table, we did have some success rate and some failure rate, because sometimes the even with the same query, it answers differently, and sometimes it even gives us a wrong answer. For example, did you see any obstacle within 0.5 meters on your path? Sometimes it just tells us no, but actually from the trajectory plot, it does get close to the obstacle. So for each query and for each model, we do at least 10 tests to see if it gives the correct answer, or if the answers are slightly different or so. So we just have a multiple test to see if the model has the proper performance or like that.
Okay, thank you.
Yeah, Sahar rejoined.
Yes.
Yeah.
Actually, I have a very bad internet connection, so maybe now I can share my screen if it works this time, hopefully. Can you see my screen?
Yes.
Okay. So to save time, I actually just can copy paste the task. For example, to plot the velocity commands in a specific time. I don't know where I got frozen in the previous, but apparently I have a very poor internet connection. Okay. So basically, we can choose different providers and different models and set the debug mode to see like what tools has been called and what are the arguments to the tools and the response. Okay, happily. So yes, in this example, we can see like the tools we have, like as Lei mentioned, we have different tools specifically for plotting different like trajectories or velocities, or the specific tools that is defined to work with the transformation.
Sahar, is there any ways you can make it bigger, because it's quite small?
Let me see. Okay. No, I don't think so.
I think if you do Control+ on your keyboard, it will zoom from the browser's point of view.
Okay,
Yeah.
okay.
Thank you.
Excellent, excellent. Thank you, Chris.
So here for the frames, so it actually used the TF3 tools that we have defined to read the transformation, and then let me try another task to. This task is specifically to requires to work with the LiDAR data, which is one of the examples that at least we tried with Bagel and it fails because they haven't, I think, specifically defined any tools to read like LiDAR data. But in this case, we have defined it. So to find the obstacle around the robot. Okay. Okay, yes. Yeah, here's it's a bit. Yes, here you can see like it reads that scan topic correctly and plot it. Let me try one more task that is kind of complex because basically it should go through all the ROSBag. For example, if you use the Bagel, it needs to spin up the ROSBag many times to set the correct query. But we have defined a specific tool for searching based on different condition that you define. In this case, like the condition is to find a specific position.
While it's thinking, do you also have tools for the image topics, or would you think of doing something like that, or how would you do something like that?
Well, that is definitely doable, because since we have tools specifically for the LiDAR that is the same, we can define tools to read and work with the image topics, like using different libraries, or even like if we can set it up with the VLMs, like here. Okay. I think I got some errors, maybe.
Yeah, so it's the same question, Christian, you asked before. For each query, for each model, actually it could fail for several times, but most we just try to get the most kind of accurate results from each model.
I think that's a very important thing to take away from this, right? Because if you think of practical applications, you have to ask yourself, where is it okay to make mistakes? And the other question, of course, is how do you know that you need to try again? So it's sort of then I guess the next question would be from a user's point of view, when should I use this, right? And in kind of what capacity, if I cannot rely on it, right? So that there's many successful products that are very unreliable. Google is actually the best example of that. Google, if you remember, they used to have an I feel lucky button, which was basically the button that they always wanted to be perfect, right? They wanted to be it such that the first hit is the one that you want. Well, it turns out that's really hard. And that's partially because it's so subjective. So they settled for showing you many results, and then sort of the user does a post-processing of the results, right? They look over the results and kind of quickly scans, and of course they help you, they show you a summary and stuff like that. And that's how they've solved it. And it's possible because it's sort of the problem doesn't have a very precise answer. So even correctness is ill-defined. So which is fine, right? And Google helps a lot. However, the queries that you ask here, unfortunately for you, they have a very yes or no answer. And that actually suggests that this is a bad approach for these types of questions, right? Because if there's no ambiguity over yes or no, then you want a tool that will get it right. So perhaps the question then becomes, what are some of the types of questions that people like to ask about their ROSBag data that do not have a strict yes/no answer, or can you somehow make it work reliably, right? I actually think the latter is much harder, so I would focus a little more on the former, because I do see a lot of value here. I just cannot say where it is, but yeah, I think either way, one would need to decide one way or another.
I think one middle ground, Christian, is to check at least that the tool invocation is done correctly, or that at least the right tools are invoked, because this is the source of the majority of the problems, indeed. Since you cannot guarantee that even asking the same query to the same LLM will result in the same tool invocation, that's exactly where the problem lies. So at least, I agree with you. You cannot fix the fact that, I mean, by the nature of the LLMs or by the temperature, default temperature of LLMs, the way you phrase a question, or even the same question might produce a different computation. And then the only way for you to check if at least it tried to do the right thing is to go and look at the debug trace of the tool invocations.
Yeah, it's interesting that you say that, because that's exactly apparently what that's the answer that Bagel gave. And in fact, they had a post on LinkedIn about this, where they say instead of, they do use tools, right? They do use SQL or whatever on DuckDB, I think. But instead of just having the LLM define the query and execute it, they will first show the user, hey, this is the query that I think I should run. Do you agree? right? And then, of course, the question becomes, is that more useful than for the person to write the query? But of course, a lot of people don't know SQL, but they might be able to read it. So it sort of solves it's a little bit like speaking a language versus understanding it. A lot of people can understand a little bit of, Spanish speakers might be able to understand some Italian, vice versa, but speaking is a different matter. So a lot of people may not be able to write a valid SQL query, but when they see it, they can say yes or no. So I like that approach, right? So you're basically saying, show me it's a little bit like in math homework, show me the method, like show me the steps that you did so I can check that you're on the right path, even if the result was wrong in the end. I think that's a good approach.
I think with Bagel, they really do the right thing. In fact, I think the post is the one where they say they don't trust LLM math, which is exactly the consequence of what you were saying at the beginning. And so then, indeed, this middle step in which you're saying, okay, I delegate the math to a database. So as long as the query that is sent to the database is correct, I expect the result to be correct. It's a very elegant approach indeed.
I noticed that there's a hand in the queue.
Yeah.
Is this a good?
Okay.
Yes. I wanted to add maybe a bit different perspective or another dimension to this conversation, touching also on the problem of completeness that you, Christian, mentioned at the beginning. So I really like, maybe first to say, Bagel's approach on the database, and I see the point in putting let's say, the pressure on the user. But I also think that queries can get very complicated very quickly. So it doesn't really scale, or it goes to very simple questions that you could also argue that LLMs will call properly most of the time. So my view is that in terms of completeness, there is a trade-off, and I think this evolved for us working on this, and also for Bagel, between letting the LLM do whatever with the data and then defining more rigid tools. Of course, if you let it do whatever, then you potentially can solve any question or any problem that you throw at it, versus giving a sort of very strict tools. And I think that maybe somewhere in between is the right answer, or I lean more towards the strictness of the tools. While we cannot guarantee that they will be called with the right arguments, I think that by designing the right set of tools, you can prevent a lot, like most of the errors, I would say even 99%, just because they would throw an error if they are called wrongly, and then basically the chances that they are called wrongly are reduced to the LLM saying that, I don't know, if you ask what was the nearest object when at 30 seconds after the ROSBag starts, then instead of 30, it puts 3 seconds. So of course, that cannot be prevented unless you just show the user the query, for example. But I think that mistake is much, much less likely than calling the wrong tools, for example. So I think that there's also a strong component on designing the right set of tools. And I would say from a usability perspective, I mean, this of course goes against generality, but I think that in a robotics context, you could already also define a large enough number of tools to work with typical data, I mean, 3D LiDAR, 2D LiDAR images, and then maybe, for example, let the users choose the number of tools before they start the program. And the reason I would do this is because in our test, when you add more tools, the performance quickly degrades, even if they are very different, because there's just too many options to choose from.
Interesting.
I think more tools degrading performance is something we saw from this presentation as well. And on that note, I realized that neither of you said you're ready for questions yet. So I think I'll hand back to you until we get to questions. But I think that was a good conversation to continue. It's another paper. It's another branch of research in itself. So
yeah, I think this it's quite a complex problem to find the balance between not just the number of tools, but also the complexity, because, for example, Claudia and Kimi can handle pretty complex tools. Then you can do more. So you can have like very general tools, and then it's all about choosing the right arguments. Right? But then you leave the small LLMs out. So then small changes to the tool descriptions is something that we notice that changes the performance significantly. So something that for us seems not so relevant, or even to the arguments. And something that Lei mentioned earlier on the context, like, for example, we have this tool that is set the path. So you can just define a bug and then continue working with that bug without specifying the full path every single time, or define a folder. But the small LLMs just forget about this, or set the one path, and then nothing else works after that. So something that sounds like super simple for us, then it becomes something really complex suddenly for the LLMs.
So, Leifu and Sahar, are you? Do you have more to show, more demo, or are you happy to take more questions?
Well, yeah, I think I'm just done with the demo, and feel free to have to ask any question if you have.
Well, thank you for the presentation. I really enjoyed having the more technical, in-depth view into stuff. I have got a whole list of questions, so I will ask one, and then I will allow others to ask further, because I'm sure I'm not the only one. So the response times vary with different LLMs, and you've got the ranges for those. Did you find that it's bag size or complexity of query? Do you know what kind of variables affect that response time the most?
Well, it is actually the combination of both, all of those, I think, because exactly it matters with the bag file. Sometimes the internet connection, or how complex the tool is, like the arguments, and how many tools it might use, because you can see that the tool usage time, latency for the tool usage are very the fraction of second, but the end-to-end latency, it actually depends on different factors, as you said, like the size of the bag, the internet connection sometimes for this web interface, or the number of tools, the complexity of the query. It actually varies a lot. Sometimes even for the same query, with the same model, again, it has different latency. So I would say this is open question.
Picking up right away on what Mike was asking, I think what I noticed in the tool for trying the MCP bags was that you produced the tool invocations after the query was completed. Instead, something that would be at least nice to see is the tool invocations as they are happening, at least, right? So that that gives you already an early feedback.
Well, that is also something that Cloud Data, for example, is doing. Based on every tool, it generates an answer and then goes to the next one. But in this interface, actually, that was kind of a personal choice to get the final result after testing or using different tools, I would say. But that's definitely something doable, I would say.
I think if there's any other questions, please go ahead. And if there's too many people asking questions, we can go to the hand queue. But otherwise, go ahead and jump in. All right, I'll jump in with another one. The lab, the MCP lab that you've got, looks like it's a nice looking tool. I noticed that every response had the icons on the bottom saying how many tokens were used and the latency and so forth. That seems really handy. I wondered if you had plans to offer the lab as a tool. And as a follow-up to that, it reminded me of Jupyter Notebooks, which gave me this idea that you could have a notebook that you plug in a particular ROSBag to, and it always asks the same query and produces the same graphs. So I thought that might be cool. I don't know if that's useful, but in terms of ML, lots of people love Jupyter Notebooks. They're really handy, and it feels like you could do something very similar. So yeah, do you have plans?
Well, that's an interesting, actually, idea. At least we never thought about right now, and we focused on using MCP servers for this interface. But I think that's an interesting idea, yeah. Maybe Jorge has some cool idea about that, but for now we have used this interface mainly for the evaluating different MCP servers. Because as Christian also asked, like you never know if they like one model can produce the same answer every time. Like the problem that we had with Cloudy Desktop was this, because you don't have option to choose different provider at least. So in this interface, actually, you can use different provider and different models. I think it has very unique features to be specifically used with MCP servers.
Yeah, I never thought about this Jupyter notebook style. That's definitely interesting. I'm not sure about the repeatability, so that's something that we need to follow in also the conversation to check. I mean, we didn't look too much into that. We saw, so okay, maybe answering first the other question. It's already available as a separate repo, so you can connect any MCP server. It doesn't support remote MCP servers, so only local, so going through STDIO basically. But I think that's something we could work on. Then about the, sorry, just a second. So one plan that we have for it, and it's something that we would like to try, that we also see that affects a lot on the performance of the tool calling, is the agent architecture. I think maybe I let Sahar talk a bit more about that, like briefly.
How, Jorge, can you repeat your question? I was like...
Yeah. So right now it implements a very simple agent in a loop, which we think is something like Cloud Desktop probably implements. But if you look at Rosa or Rai, they implement other agent architectures like React agents. Then even when you have it in a loop, you can set like how many tool calls you allow per iteration, if you allow for parallel tool calls or not, how many iterations you allow for the LLM to do on itself if it comes back. This is something that we haven't seen any other sort of MCP test bench tool provide, and that at least in this context, we think it would be really useful for not debugging, but developing and finding like which aspects actually matter the most in terms of performance.
Yes, exactly. Because like in this version that we have, we are using just very simple tool calling agent, nothing fancy like React or any multi-agent, but we just kept it very simple to make sure that it is running and working with very simple, just LLM using tools. So I think the performance would actually improve when you use more kind of smart agent like React, for example, or in different multi-agent system. So this MCP Lab, actually, you can like modify it to, or we can like have different version to set different agents instead of very simple agent. In that case, actually, by providing more prompts, like system prompts, how to use different tools, I think you can reduce the hallucination also of the tool calling a lot, if it is used in the agentic way, because this is not agentic way. This is just very simple tool calling agent.
And I think here, I don't know how many are familiar with the concepts that you were discussing now. For instance, React, and because this is the Cloud Robotics working group, so we typically work with Cloud and Robotics. Yeah, so maybe you could tell also a bit about this one, because I don't know, Michael, Christian, all the others, I don't know how familiar we are with
React is a web framework to me.
Okay. So in this like in this interface, actually, you can imagine that it is this like a list of tools connected to an LLM. That's basically all. But this LLM can be more fancier. Like it can has a different modules, like reason it, use some prompts that how to use these tools, take some examples how to use these tools. So in that case, it can be used as an agentic kind of system. And if you use it in that way, you can reduce the hallucination also. But this interface is like just simple agent, simple LLM, let's say.
Yeah, so maybe to give you an example, you can use LLMs for doing what is called chain of thoughts. Chain of thoughts means the LLM produces a reasoning trace and then uses this reasoning trace to somehow process it again and go on talking to itself. So this is chain of thought. Then you could have action only, which is basically tool calling. So the LLM has a set of available actions that change the environment. The environment gives a context, and the observations of the environment trigger the next invocations of the tools. And then you can have React. React is something that has both these things. You have a reasoning trace that gives you some context about what you are doing, and you have actions that have an effect on the environment that change the context, give you observations, and you basically use the observations with the reasoning traces to decide what you do next. So this is why Sahar was saying, if you change the way you are implementing this somehow loop that is used for doing the tool calling, this has been demonstrated, at least React, the seminal paper, React, was exactly about what Chris was asking at the beginning, how to improve the way that LLMs do things. And React is one of the, let's call it patterns that can be used for somehow improving this.
So in that kind of chain of thought, can you also have a step for checking its own answer?
Well, checking its own answer is a bit, it does. I mean, it looks at its own answer, and that's exactly what chain of thought does, indeed. But I'm no expert. Again, I was just trying to bridge the fact that there's a whole world now about agentic AI and the way LLMs are interacting with tools, with other agents, which is being defined as we speak, and there's a lot of things coming up. And MCP is, a big technology in this aspect.
One way to increase reliability, of course, is to redundancy, right? And the redundancy that comes to mind here is to come up with two different approaches to compute the same result, and then see whether you come. This is a little bit like test cases, right? A test case, obviously, when you write code, you write it in a way where it should be correct. And then a test case, in some ways, is just another way to compute the result and compare it to the code. And sometimes you just hard code it, so you just do it on paper. Sometimes there's some other more abstract or simplified, I should say, computation involved. I wonder whether that principle could apply here, especially because you have multiple tools. And I'm still struck by this insight that more tools make things worse. It sounds a little bit like cacophonia, like when you have too many voices speaking all at once. But a way to do that, we also know, is like there's these famous experiments where they asked like 100 people to estimate the weight of a cow just from looking at it, and these people knew nothing about cows. But if you ask a very large number of people about the weight of a cow, the average that comes out is astonishingly close to the actual weight of the cow, and in particular closer than if you ask just a handful of experts. So what I'm trying to get at is, can you sort of turn this problem of too many tools into a positive by, and I guess in ML this would be roughly in the domain of mixture of experts, but some sort of checking each other. Like I'm not a big fan of voting, right? Like where you sort of average the results, but at least as a filtering mechanism, because we are talking about yes, no answers. If you can run 3 tools and they come out to the same result, then we obviously want to trust it more than otherwise.
That's a nice idea.
I can show what we are doing for the tool schema, because if you have multiple tools that actually have some overlapping, for example, you can have more content in the same schema input than LM has. So the LM is basically showing all the schemas at the beginning. So if you have multiple tools getting the same input and having similar content, they might be confused. So more tools means more text for the LLM to decide which one to do and which one to core. So it could add more difficulty for it to give the correct answers. Yeah.
Yeah, maybe to add to this, I'm not 100% sure that that's how MCP works, but basically my understanding is, as Lei said, that these schema definitions are basically fed at the LLM when all the available tools are shown. Basically, it's like adding it to the context. So having more tools means a lot of this sort of text that then it confuses it in the sense. I was just wondering right now, I don't know if this makes any sense, but basically, if there was a way to see the schema or the LLM could, this would add a lot of latency, but basically, we could present this in a sort of summary of information to the LLMs and then make it request tool descriptions on demand. This might allow us to have many more tools, but I don't think that's easily implementable right now, like out of the box, at least. But at least one of the reasons that I believe it seems that the great performance is that there's so much information given to the LLM initially with these tool descriptions. And that's why more tools not help. I guess also at the same time, if you could make them very clearly different, then that might reduce the problem. So the less similarity between the tools, maybe the less effect or the less degradation.
Yeah, I think that's all of my questions. All of my other questions were answered during the presentation. So, for instance, can you pass the path of a ROSBag? Can you scan across multiple bags? I think you were setting a path to a folder, right? That means that you could feasibly host something like this in the cloud with access to a whole bunch of ROSBags that you keep adding to, and you can keep running the same tools on it.
Yeah, you can list all the ROSBags in one folder, and it can also list all the topics in different ROSBags. Yeah.
And that means that we've successfully fitted the word cloud into this recording somewhere, which means...
Well done.
Yes, right at the end. But I think that's a great point to end. Thank you for coming and talking to us about your research. I think that was really interesting. Had some good insights there and learned a lot more. Next session, we'll be back with AMP Robotics. So Carter here has agreed to come and talk to us about AMP's... can I just call you AMP? AMP's use of a robot fleet.
We rebranded. We're no longer AMP Robotics. We're supposed to make everyone call us AMP now because we are moving away from robots and into doing full facilities. But yeah.
So I'm ahead of the curve.
Yeah.
Is that expanding to more, or are you actually getting rid of robots?
We are doing less of like selling our robots to other people and more of like building our whole own system that we're running and operating ourselves. And so, it's pivoting the customer model quite a bit.
Bigger, higher vertical integration, but the technology will still involve robots? Okay.
A lot less, a lot more air jets.
Yeah, interesting. Well, looking forward to your talk. Good to catch up.
We can hear more about how a large fleet is operated with logging and observability, which I think will fit nicely with our community guide. It's what we were talking about last session that we needed more of. So appreciate you agreeing to join us. And I think we have a couple more minutes. If anyone's got any more questions, now's the time. So I'll pause briefly for that.
Well, if there's no other questions, I'm always curious about what's next. Can you perhaps share a little bit about future work or what you want to work on next?
Yeah, actually, I have the last slides about the future work that I forgot to mention. Yeah, so what our well, for this ROSBag MCP server, we will just find a way to optimize the schema description and enable context-aware tool training and adapting tool exposure to each model's strengths. But our like final goal is to realize to achieve the real-time robot control and multi-robot coordination, which we can kind of describe it as a robot brain that we just use a natural language to talk to the robot and to ask the robot to do whatever you want without any robotics expertise as a robotist. Yeah, so that's what we want to do in the future with different MCP servers, and this ROSBag one is just our first trial. Yeah.
Maybe connected to the ROSBag, so it would be nice to see it live, so that you could ask, what did you see 10 seconds ago, 1 minute ago, or where did you last see this, but not from a ROSBag, but in a live system.
Yeah.
I'm also quite curious to see how well it would do with a VLM. So in this session, did you see such and such a person or object or whatever it is? I think that would be pretty cool. But yeah, live robot control, also very cool. So with that, I think, thank you for attending. That will be the end of the session. See you next session, and thanks for coming.
Thank you.